All right, this is 5.7, subtract linear expressions. To review from last lesson, linear expression is an algebraic expression in which the variable is raised to the first power and variables are not multiplied or divided. So if you look at that, you're looking at the k is to the first power. We're not multiplying a k times a g or something like that, okay? So we have a linear expression. I'm going to kind of draw this, what this would look like. It would look like 5k's, 1, 2, 3, 4, 5. These all be multiplied together, 6, and then plus an extra 1, 2, 3, 4, 5 numbers. And when we talk about subtraction, we're getting rid of things, right? So if I'm subtracting 2k's, that would look like this. And I'm subtracting 3 positives, 1, 2, and 3. What are we left with? We're left with 4k's and a 2. Now, what your teachers will tell you is to line these up. 6k plus 5. Make sure you get your k's lined up and your numbers lined up. You're doing subtraction. And then you could just do 5 minus 3, which is 2. 6k minus 2k, which is 4k. And put the sign back in between them. They might teach you to do leave change opposite, which means you would actually change the entire thing. So that means that would become a negative 2k, and that would become a negative 3 that you're then adding. And again, 5 plus negative 3 would be 2. 6k plus negative 2 would be, 2k would be 4k. And so either way, you're going to get 4k plus 2. And I like to ask my kids how many terms. There are 2 terms. That is the constant, the k is the variable, and the 4 is the coefficient. And you can't solve it at this point unless we tell you what it's equal to or what k is worth. So I want to show you one that's a little bit tougher. So I have 6y plus 2, and I have it represented here. And I want to subtract 8y, okay? And I want to subtract a negative 4. What you might notice is you can only subtract 6y's. 1, 2, 3, 4, 5, 6 y's, right? And you need to subtract 2 more y's. Well, that's where we would put in what is called a zero pair. I could add a y and a negative y because they would cancel each other out, and I could do that a couple times if I needed to. Now I would have enough to take away the 6 that I took away and 2 extras, and your answer is going to end up being negative 2y as far as the y's go. And I need to subtract negative 4, right? But I don't have any negatives. So again, I could put in a zero pair of a negative 1 and a positive 1, a negative 1 and a positive 1, a negative 1 and a positive 1, a negative 1 and a positive 1. And now I can subtract 1, 2, 3, 4 negatives. And what you end up with then is 6. So our answer would be negative 2y plus 6. Another way is to line them up again. I would suggest again that you do leave change opposite, which means that's going to become a plus a negative 1, and that negative 1 gets distributed, which makes that the opposite, and which makes that the opposite. And now you're in addition. So then you can add your 2 plus 4 and get 6. You can do your battle between these two that have different signs. The negatives win it by 2. Put your plus back in between, you'll get to your exact same answer of negative 2y plus 6. 2 terms, constant of 6, variable of y, coefficient of negative 2, and can't solve it unless you know what it's equal to or what y is worth. So let's practice that a couple times. I need to subtract the value 7k plus 5. And I'm going to do leave change opposite, which makes that an addition problem, but it changes everything to its opposite. Okay, so 14 plus negative 5 then, different signs, subtract. Put the plus back in there. 9k and negative 7k, they fight, and I have 2k's. The answer is 2k plus 9. Let's try that again. Leave change opposite I would do anyway, right? Now, when I line these up, these are in the wrong order, so I'm going to switch the order, okay? I'm going to switch these using the commutative property. So I'm going to write the 5 up here to the negative, and the 4g back here. And remember, I'm subtracting these things, so I want to go to the opposite, leave change opposite, so that changes that to a plus, which makes that a plus, and that a negative. Now, when I add them, 9 and 5 have the same sign. Add and use that same sign. The g's also have the same sign, so add and use that same sign. Okay, you can do that again. The y's are in the right order. Now you do have to make sure you keep track that the y minus 8 is the one you're starting with, so it needs to be on the top of this subtraction problem. So I'm going to be subtracting a negative 5y plus 6, except that I'm not going to subtract. I'm going to do leave change opposite, so I'm adding the opposite of that and the opposite of that. Should do leave change opposite up here. The y's have the same sign. 5y plus another y is 6y's. And negative 8 plus negative 6, they have the same sign, so that'd be negative 14. And of course, remember, this could be written as 6y minus 14. You could use the commutative property and write it negative 14 plus 6y. There's a number of different ways it could look. Okay, here's another one where we're going to have to change the order, so I'm going to make sure I do leave change opposite so I can change the order. Then I can use the commutative property to write the h's on the back and the constants on the front. This is what I'm subtracting, so I'm going to do leave change opposite, the opposite of this, and the opposite of this. The constants are on the same team, add and use that same sign. The variable terms are on different teams. They fight, and the positives win it by 2. So I did an entire page kind of that way of lining them up. I'm going to also show you another way, which is an understanding of the distributive property, which we've already covered. So remember, there is an understood one of those groups, and there's an understood one of those groups. I would still continue to do leave change opposite, and you have to do leave change opposite on that middle one right there. And then you can just do the distributive property. Well, the easy thing about that is 1 times anything is just that thing. So you're basically busting it out of jail, and it just becomes that exact same thing. And negative 1 times anything is just the opposite. So it's going to be the opposite of 4, which is negative 4, and the opposite of negative f, which is f. And then you're just combining like terms. So you have 9f and f, which is 10f. And you have negative 2 and negative 4, which is negative 6. And you got your answer. So here's what that looks like again. I have an understood one group. I have an understood one group. I'm going to do leave change opposite. 1 times anything is itself. That's the identity property. This is actually the inverse, right? Times negative 1 is its opposite. Times negative 1 is its opposite. And then you're just combining like terms. 4c and 8c is 12c. 3 and negative 7 fight, and the negatives win it by 4. So I'll do this problem both ways. So I have a 6w plus 8. I want to subtract from it a 9w minus 5. It's important, you know, we're subtracting that entire linear expression from the first linear expression. So leave change opposite. And then I'm going to do leave change opposite, which means this becomes a negative and that becomes a positive, because I have to change everything to its opposite. Now I'm ready to add. I get 13. These guys fight, and I get negative 3w. If I were doing it with the distributive property, 1, 1, leave change opposite, leave change opposite. 1 times anything is itself. Negative 1 times anything is its opposite, so the opposite of that is a negative 9w. The opposite of that is a 5. Now I combine like terms. They fight, I get negative 3w. They're on the same team. I add them, and I get negative 3w plus 13. Again, both ways. So I could do 2b minus 1, subtract from it a 3b plus 8. Do leave change opposite right there, and I'm going to do leave change opposite right here, which makes that a negative and that a negative, because we're the opposite of everything. Now I'm adding. These guys are on the same team. These guys fight, and the negatives win it by 1. So we get negative b plus negative 9. And some people will write negative 1b. That's the same thing. If not, I'm going to do it with the distributive property. So I'm going to put my understood ones in there. I'm going to do some leave change opposite. And now I'm ready to distribute. 1 times anything is just itself. Negative 1 times anything is its opposite. So that becomes a negative 3b. And that becomes a negative 8. And now we're ready to combine like terms. They fight, and you get the negatives winning it by 1. They're on the same team, so we add and use that same sign. Negative b plus negative 9. Right, the reason I think it's important to learn the distributive property part of this is sometimes you have different sets of these. I have 4 of these, and I have 2 of these, if that makes sense. And so now I can't just subtract them because I have 4 of one and 2 of another. So I need to kind of do the distributive property. So I'm going to do leave change opposite, get rid of all my subtraction. Now I'm going to do the distributive property. 4 times 3e is 12e. 4 times a negative 5e, that's 1 negative, so it makes it negative. 1 negative makes this negative, and 2 negatives makes that positive. Now I'm using the commutative property to get my e's together. They're on the same team. And to get my constants together, they're on the same team. We have our answer of 20e plus negative 32. I think a lot of kids find these negatives right in front of the one here to be kind of confusing. So if you'll remember to put that 1 in there, you can put the 1 in front of that j too if you want. Put that 1 right there. Those 1s kind of help you to see what's going on. So I'm doing the opposite of this, which becomes a negative 5 and a positive j. And then I'm doing the opposite of this and the opposite of this. Now I get my like terms together. They fight, and the negatives win it by 5. They're on the same team. Add and use that same sign. You get negative 5j plus negative 13. Again, leave change opposite. Distributive property. 1 negative makes it negative. 1 negative makes it negative. 1 negative makes it negative. Now get your like terms together. They're on the same team. Add and use that same sign. Constants, they're fighting, and the negatives win it by 18. Of course, remember, this can look different ways. You could have the negative 18 first and the negative 14k second. You could have it as a subtraction problem, negative 14k minus 18. So that's just doing leave change opposite and changing it back to minus a positive instead of plus a negative. All right, last example, leave change opposite. Distributive property, 8 times, remember there's an understood 1 there, so 8 times negative 1v is negative 8v plus 24 plus 2 negatives makes this positive. 1 negative makes this negative. Get your like terms together. They fight and the positives win it by 2. They fight and the positives win it by 10, and your answer is 2v plus 10.